Tonight our notes are going to be talking about the distributive property. So as always, please follow along with whatever I write. If I write it, I would like for you to please write it in your notebook because it's going to be important. We're not going to take notes on this in class, so it's essential that you take notes at home. The distributive property is an algebraic property. It's a rule, a law that allows us to essentially multiply a group of terms by one factor. So the group of terms may be seen as a sum, like in this case, b plus c, or you might see it as a difference. So we might have a times b minus c. So it's either multiplying a sum or a difference. And it's important for us to use the distributive property in algebra specifically when we have variables, because if we had something like 2 times 3 plus 5, well, if we wanted to simplify this, we would probably use the order of operations or our GEMDAS or PEMDAS. And if we use this to simplify, we would look for grouping symbols first. I have 3 plus 5. I can add those together and I get 8. And then we multiply that by 2 and get 16. Okay? So the distributive property, we could use it with just numerical expressions like this one, but we need it when we have algebraic expressions. So what if we had something instead of 2 times 3 plus 5, what if we had 2 times x plus 5? If we wanted to simplify this, following the order of operations would tell us to use grouping first. But what would we get when we simplify x plus 5? X is a variable, 5 is a number. We can't actually simplify that to anything else. So this is where the distributive property becomes important, when we can no longer use GEMDAS. So here's what the distributive property says. It says that if I have a sum or a difference, and I'm multiplying it by a factor in front, or it might actually come behind the parentheses, instead of multiplying or doing the sum first and then multiplying that number by the first number, we're going to multiply each term, so b and c, by a, and it looks like this. So we're going to do a times b, and we write it as ab, plus a times the second term, c. Same thing with the difference. Instead of simplifying b minus c first and then multiplying by a, we're going to distribute that a to each term. So a times b will be the first term, ab, minus, in this case, a times c. So this is that distributive property with all variables. So what would that look like with our expression 2x, 2 times the quantity x plus 5? Well, first, we're going to multiply 2 times x, and we get 2x. Second, we're going to do 2 times 5. So plus 2 times 5, which gives us 10. 2x plus 10 is a lot easier to work with. Can we combine these two terms? Well, this has a variable and this doesn't. So this is actually as far as we can go. That's our final answer, 2x plus 10. So let's get some additional practice using the distributive property. So how about our example is 4 times x minus 7. So this distributive property tells us to multiply the outside number first by the first term. So that'll leave us with 4 times x. And then again by the second term. So 4 times 7. So notice what I did here. If you have subtraction like this, I just brought that subtraction symbol down and counted this as a positive 7. Notice this is a positive 7 here. The other way to do this would be you would do your 4 times x and you'd get 4 times x. And then if you wanted to treat this, I'm going to write it a little differently, so I have x minus 7. If you wanted to treat this as a negative 7, what you could do is always put a plus sign, and after your 4 times x, you could write it as 4 times negative 7. So I'll show you how both ways we're going to be able to get our answer. So let's say we stuck with this first way. 4 times x just simplifies to 4x minus 4 times 7, which simplifies to 28. 4x and 28 cannot be combined because they are not like terms, so we're going to leave our expression that way. Let's say we did it this way. So 4 times x gives us 4x plus 4 times negative 7 gives us a negative 28. Now, you don't want to leave two operators right next to each other like that. So if you have plus a negative or minus a negative, you're going to want to go ahead and simplify that to, instead of plus negative 28, it's just minus 28. So either way you do it, you're going to get the same answer. Sometimes it's beneficial to keep that term, keep the operator, and sometimes it's more beneficial to just have a plus sign and make that a negative number. It really just depends on the example. So let's see a couple more. How about we have negative 3 times 2x plus 5. So we're going to multiply negative 3 times the first term, 2x. Negative 3 times 2x. Then we're going to multiply negative 3 by the second term, which is 5, plus negative 3 times 5. So notice I kept that plus sign in between the 2x and the 5. Negative 3 times 2x will give us negative 6x plus negative 3 times 5 is negative 15. I don't want to have a plus negative 15, so instead we're just going to get rid of that plus sign and say negative 6x minus 15. Let's do another example. So this time let's have 5 times 4 minus 8x. So the variable doesn't always have to come first in the quantity. It usually will, but it doesn't always have to. So take that 5, multiply it by the first term, 4. So we have 5 times 4. Then I'm going to keep a minus here, and I'm going to treat this 8x as a positive 8x. So I'm going to say 5 times positive 8x. And that subtraction just came down. 5 times 4 will give us 20, minus 5 times 8x. 5 times 8 will give us 40x. If you were given answer choices with the variable in the first term, your answer choice might look like this: negative 40x plus 20. So they may switch around those terms to have the variable in the front. For our next example, let's have negative quantity 2x minus 7. So all we have is a negative sign in front of our 2x minus 7. So what coefficient are we actually going to be distributing? What is that factor? Anytime you have a negative by itself, it's representing a negative 1. So what we're really seeing is negative 1 times the first term, 2x. So negative 1 times 2x. I'm going to leave the minus here and treat this as a positive 7. And again, then I have negative 1 times positive 7. So let's simplify. Negative 1 times 2x becomes negative 2x minus negative 1 times 7 is negative 7. I have a double negative here, minus negative, so this can become a positive. So negative 2x plus 7 is our simplified answer. Take a look with what we started with before we actually worked out this problem. We started with negative as a coefficient and then times the quantity 2x minus 7. Look at what we ended with. We ended with negative 2x plus 7. So if you are ever distributing a negative, all it does is make the signs of each term opposite. So when distributing negative 1 the signs of each term flip. And what I mean by that is if we start with 2x, it's going to flip and become a negative 2x. If we start with a minus 7, it's going to become a plus 7. So they go from negative to positive and so forth, or positive to negative. That's something that you're going to notice whenever you're distributing a negative. It's always going to change those signs. The last examples we're going to look at are when we're distributing a factor, but the factor might actually be to the right of the quantity instead of in front of it like we've been seeing. And you can still use the exact same thing, it just looks slightly different. We're still going to distribute a 4 to each term inside the parentheses. So we're going to start with 4 times x, plus 4 times y, and then that 4 has been distributed, so that goes away. And we simplify that to 4x plus 4y. And we cannot combine those terms because they have different variables. Let's look at another example where the factor being distributed is on the right. This time let's have quantity of 2x plus 3 minus y, and let's distribute the number 5. So this is slightly different than what we've seen because it has 3 terms. That's okay though, we're still going to follow all of the same steps. So we're going to take 5 and we're going to distribute it to the first term. We're going to multiply 5 times 2x. Okay, then we're going to multiply 5 times 3. I'm going to bring down this minus and multiply 5 times positive y. So notice I didn't change any of the signs. And let's simplify. 5 times 2x leaves us with 10x plus 5 times 3, which is 15, minus 5 times y, which is 5y. So you can distribute and actually end up with 3 or even more than that, more terms than that. 10x, 15, 5y, they're all completely different terms, so they cannot be combined. I hope this helps you understand the distributive property. If not, definitely look online. Khan Academy has some great videos as well as math antics. And good luck on your practice questions tonight.